Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into a deceptively simple question, one that sounds almost playful at first, but slowly opens into something vast and strangely intimate. How far could a human actually travel through space in a single lifetime? But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly find these quiet explorations enjoyable. And when you're ready, feel free to leave a comment letting me know where in the world you're listening from and what time it is for you right now. It's always a small wonder to imagine all of us scattered across the planet, each resting in our own pocket of night, connected by the same gentle curiosity. Now, you might want to dim the lights a little. Maybe turn on a fan for a soft, steady hum, or adjust your pillow just once more. And if your thoughts begin to drift as we go, that's perfectly fine. Let them wander. We'll keep moving slowly, together. Tonight, we're not chasing rockets or counting down launches. We're simply going to ask what it really means to go far, and what far even means when time, distance, and a human life all refuse to line up neatly. So take a slow breath, let your shoulders drop, and let's begin. Session 1. The question that sounds simple. There is something quietly irresistible about the idea of going far. Even as children, we feel it. The urge to walk just a little farther down the road, to look past the horizon, to ask what lies beyond the last hill, the last ocean, the last familiar star in the sky. Space, more than anything else, seems to invite that question. It stretches out above us every night, calm and patient, sprinkled with points of light that feel close enough to touch, yet impossibly distant at the same time. So the question forms almost naturally. If you had a whole human lifetime, not rushed, not cut short, but a full span of years, how far could you really go out there? How much of the universe could a single person cross, simply by living and moving forward? At first, the question feels almost mathematical, as if it should have a clean answer. You might imagine a fast ship, a long journey, a steady line moving outward from Earth. Distance equals speed multiplied by time. It sounds tidy, comforting even. But space has a habit of gently undoing tidy ideas. To begin with, we need to pause and notice something we rarely think about in everyday life. Our sense of motion is deeply local. On Earth, we are used to distances that make sense to the body. A walk across a room, a drive across a city, a flight across a continent. Even the longest journeys we usually take still fit neatly inside a human scale. Hours, days, maybe weeks. Our minds are very good at handling those. Space does not play by those rules. When we look up at the night sky, our brains quietly lie to us. The stars appear as a flat backdrop, like pinholes in a dark curtain. They feel almost decorative. But each one is separated from the next by distances so large that the idea of between starts to lose its meaning. Even the nearest stars are not neighbours in any familiar sense. They are islands scattered across a cosmic ocean that has no roads, no landmarks, and no shortcuts that feel intuitive. And yet the question remains, how far could you go? To answer it, we have to untangle two ideas that are often mixed together without us noticing. The first is distance. The second is experience. Distance is what maps care about. Experience is what a human life actually feels like. Space, as it turns out, is far more interested in distance than in our feelings about it. Imagine for a moment that you're standing at the edge of a vast desert. Not a desert you could cross on foot, but one so wide that even the concept of crossing starts to feel abstract. Now imagine that someone hands you the fastest vehicle ever built. You climb inside, you set off at top speed, and the landscape begins to slide past. Hours turn into days, days into years. From inside the vehicle, you are moving, you are living. You're doing exactly what the question asks, but the desert barely notices. This is the first quiet truth of space travel. Motion does not guarantee progress in any meaningful sense. You can move faster than anything humanity has ever created and still remain, by cosmic standards, almost perfectly still. The universe is not impressed by speed the way we are. It measures movement with a different ruler. There is also a subtle emotional trap hidden inside the question itself. When we ask how far a human can travel in one lifetime, we often imagine that lifetime as something fixed and shared. We picture years passing at the same rate everywhere, as if time itself were a universal background music, playing steadily no matter where you go. That assumption feels natural, because it matches our everyday experience. A year is a year. A birthday comes once, then again, then again. But space does not promise to keep time that way. As we move faster, as we leave familiar gravitational surroundings, time itself begins to behave less like a steady clock and more like a soft, stretchable fabric. It slows, it bends, it disagrees with itself. And this is where the question quietly transforms. It stops being only about distance and becomes something deeper. How far can you travel before time itself begins to separate you from everything you left behind? There is a reason this question has haunted scientists, writers, and dreamers for generations. It sits right at the intersection of curiosity and loss. To go far is to leave is to change, and in space, change does not happen evenly. It happens in layers, some visible, some subtle, some irreversible. As we continue, we will move gently from what humans have already achieved to what physics allows in principle, and finally to what the universe itself will permit. There will be moments of wonder, moments of quiet limitation, and moments where the answer turns inward, toward what it means to belong to a particular time at all. For now, it's enough to sit with the question in its simplest form. How far could you go if you lived a full life and never stopped moving? Let that thought settle, like a stone sinking slowly through dark water. We'll follow it, patiently, and see where it leads. If we want to understand how far a human could travel in a lifetime, the gentlest place to continue is with the fastest things we already know how to make. Not imagined ships or future dreams, but real objects that exist right now, built with careful hands, tested with patient mathematics, and released into space with a quiet hope that they might go just a little farther than anything before them. Speed, after all, feels like progress. When something moves faster, we instinctively believe it is going somewhere meaningful. One of the fastest creations humanity has ever launched is a small, sturdy spacecraft sent toward the sun. Its journey was not meant to carry people, or even to explore distant stars. Its task was much humbler and much more dangerous: to skim close to the sun itself, diving through intense heat and radiation to study the solar wind. To survive, it carries a thick heat shield, always facing forward like a raised hand against a blazing fire. As it falls inward toward the sun, gravity does something remarkable. It steals altitude and gives speed in return. Each close pass accelerates the spacecraft faster and faster until it reaches velocities so high they're difficult to imagine in daily life. Faster than any jet, faster than any bullet, faster than anything humans have ever ridden. Numbers can describe this speed, but numbers are not especially kind to the sleepy mind. So instead, imagine this. If that spacecraft was skimming just above Earth's surface, it could cross an entire continent in minutes. It could circle the planet again and again while a cup of tea was still cooling on the table. It is, by every human measure, astonishingly fast. And yet, when we turn our gaze outward, toward the nearest star beyond the sun, something quietly humbling happens. That nearest star is not next door. It is not even down the street by cosmic standards. It is separated from us by a gulf so wide that even light, the fastest messenger the universe allows, takes more than 4 years to cross it. Light does not slow down for fatigue. It does not rest. It simply moves endlessly and still needs years to arrive. Now imagine sending our fastest spacecraft on that journey. Not slowing down, not stopping, just flying straight, forever, at its record speed. From the perspective of a human life, it would barely begin. Decades would pass, then centuries, then millennia. Long after languages changed, cities rose and fell, and the memory of the launch faded into a footnote of history, the spacecraft would still be drifting through the dark between stars, having covered only a small fraction of the distance required. This is the moment where our intuition gently breaks. We are used to speed meaning escape. On Earth, speed lets us leave places behind. It compresses distance. It makes the world feel smaller. But space does not respond the same way. Space is not impressed by speed. It responds only to time, and it demands a great deal of it. If you take the length of a full human life and stretch it end to end, from birth to old age, and then pour all of that time into forward motion at the fastest speed we can currently achieve, the result is surprisingly small. Not even enough to reach the nearest star. Not even close enough to feel like a journey that has truly begun. This does not mean we are slow in an absolute sense. It means the universe is vast in a way that resists compression. It refuses to be rushed. There is a quiet psychological effect hidden in this realization. When we hear about record-breaking speeds, our minds naturally celebrate them. Fastest ever. Furthest yet. These phrases feel triumphant. But when those same speeds are placed against the scale of interstellar space, they become almost tender, like a child running bravely across an empty field, unaware that the field has no visible end. This contrast is important, because it sets the emotional tone for everything that follows. If even our greatest speeds barely move us between stars, then the question of how far can you go must be asking something deeper than raw velocity. It must be asking how distance, time, and human experience intertwine. There is another subtle detail worth noticing here. These fastest spacecraft were never meant to carry people. They are uninhabited for a reason. They cannot slow down and stop where they're going. They cannot turn around easily. They cannot protect fragile human bodies from radiation, isolation, or time itself. They are messengers, not travelers. This distinction matters because it hints at a truth that will return again and again as we drift forward. The universe allows small objects to move fast more easily than it allows living ones to do the same. Speed is simpler when there is no one inside to feel it. So when we speak of how far a human could travel, we're not simply scaling up what machines already do. We're asking whether a living timeline can fit inside a cosmic one. Whether decades can meaningfully confront distances measured in light years. Whether motion alone is enough. As this understanding settles, the question subtly shifts its shape. It becomes less about chasing speed records and more about redefining what progress through space truly looks like. Perhaps going far does not mean moving fast in the way we first imagined. Perhaps it means changing how we think about time itself. That idea does not arrive all at once. It emerges slowly, like a distant glow on the horizon. And as we continue, we will let that glow grow brighter, one calm step at a time. For now, it is enough to rest with this image. The fastest things we've ever built, racing bravely through space, still barely beginning their journey when measured against the stars. The universe is not cruel about this. It is simply vast. And in that vastness, it invites us to rethink what it means to travel at all. Once we accept how fast our fastest machines really are, the next gentle step is to bring the question closer to home. Not to spacecraft, but to ourselves, to the length of a human life, measured not in dates on a calendar, but in mornings and evenings, in habits that repeat, in memories that slowly pile up, and then, just as quietly, begin to fade. A lifetime feels long from the inside. 80 years can feel like an ocean of time when you're living it day by day. Childhood alone seems endless. Summers stretch wide. Waiting feels eternal. Even adulthood, when time appears to speed up, still contains thousands of ordinary moments. Meals eaten, steps taken, conversations half remembered. From within that flow, it feels natural to believe that such a span of time should be able to carry us a great distance. Space disagrees. To understand why, imagine shrinking your entire life into a single, unbroken line. From your first breath to your last quiet sleep, every second laid end to end. Now imagine attaching that line to motion, letting it pull you forward through space without pause. No detours, no stops, just steady travel, year after year. On Earth, that kind of uninterrupted movement would be transformative. You could circle the planet many times. You could cross continents again and again. The world would feel conquered by distance alone. But once we lift that same lifetime off Earth and place it among the stars, something unsettling happens. The line that once felt so long becomes thin, almost fragile. Against the backdrop of interstellar space, it barely scratches the surface. One way to sense this without numbers is to think about walking. Imagine standing at the edge of a vast plain. Not a field you can see across, but one that disappears into haze long before the far side reveals itself. Now imagine you're told that you may walk for the rest of your life at a steady, comfortable pace without ever stopping. You begin. Days pass, years pass. Your footsteps accumulate. You feel the effort. You feel the passage of time in your bones. And yet, when you look back, the distance covered is still only a tiny fraction of what lies ahead. Space amplifies this feeling dramatically. Even when moving at speeds that seem absurdly high by everyday standards, the sheer scale of the distances involved reduces decades to something like a rounding error. A lifetime becomes a brief gesture rather than a journey. This is not because human lives are short in any moral sense. It is because space is old, wide, and stubbornly indifferent to how long we feel we've been here. The universe has been expanding for billions of years. Its structure was laid down long before humans learned to count time at all. Compared to that history, a single lifetime is a flicker. There is also a subtle trap hidden in how we imagine progress. We often picture motion as linear and cumulative. If you keep moving, you must eventually arrive somewhere meaningful. That logic works beautifully on roads and oceans. It fails quietly in space. Between stars, there are no halfway towns. No familiar landmarks that make progress feel tangible. There is only emptiness, stretching far beyond the reach of human patience. You can move through that emptiness for decades and still be closer to your starting point than to any destination that matters. This is why phrases like "within a lifetime" are so misleading when applied to the cosmos. They carry emotional weight, but very little physical leverage. A lifetime is enough to experience, to learn, to love, and to change as a person. It is not by default enough to cross the spaces between stars. And yet, the mind resists this conclusion. It wants to bargain. What if we go just a little faster? What if we never slow down? What if we push harder, burn brighter, refuse to accept the scale of things as they are? These questions are not foolish, they are deeply human. They arise from the same impulse that once drove people across oceans with no guarantee of return. But space is not an ocean. It does not curve gently around a planet and bring you back home. It opens outward, endlessly, without regard for the rhythms of human life. This realization can feel disappointing at first. It sounds like a closing door. But in truth, it is simply the universe being honest about its dimensions. It tells us that if we want to go far, truly far, we may need to rethink what going even means. Perhaps distance alone is not the right measure. Perhaps time itself must be treated differently. Perhaps the limitation is not how fast we can move, but how we experience the passage of years as we do so. That thought does not solve anything yet. It merely waits, like a quiet idea resting at the edge of awareness. As we move forward, it will return, reshaped and clarified, offering a different way to answer the original question. For now, let this settle gently. A human lifetime, rich and full from the inside, is still astonishingly small when set against the architecture of the universe. Not because we lack ambition, but because the cosmos is built on a scale that asks us to be humble before it. And in that humility, something important begins to shift. The question stops being about racing outward. It becomes about understanding the rules of the journey we're already on. As the idea of distance settles more deeply, the mind often reaches for a familiar milestone, something concrete and reassuring. Surely, we think, we have at least left our home system by now. Surely humanity has already crossed that symbolic threshold, stepping out of the sun's domain and into true interstellar space. The answer to that thought is both yes and no, and the difference between those two answers reveals something important about how space quietly resists our intuition. Several decades ago, a small spacecraft began a slow, patient journey outward from Earth. It carried no people, no plans to return, and no expectation of ever arriving anywhere in particular. Its mission was simple: to keep going. Year after year it drifted farther from the sun, passing the orbits of the planets, moving through regions that no human-made object had visited before. Eventually it reached a boundary that scientists had predicted but never touched. This boundary is not made of walls or fences. It is invisible, silent, and defined entirely by pressure. On one side, the sun's influence dominates, blowing a steady stream of charged particles outward like a cosmic breath. On the other side lies the thin, restless gas between the stars. When the spacecraft crossed that boundary, it sent back a quiet confirmation. Humanity had, in a limited sense, stepped outside the sun's immediate bubble. Headlines celebrated the moment. It was called a departure from the solar system. And yet, something about that phrase is misleading. The boundary that was crossed is not the edge of the sun's reach. It is only the edge of its wind. Beyond it, the sun still holds on gravitationally, its invisible pull stretching far into the dark. Gravity, unlike wind, does not fade quickly. It thins slowly, patiently, over enormous distances. If the solar system were a city, this boundary would be like stepping beyond the sound of traffic, not beyond the city limits themselves. The sun's gravitational presence extends much farther, enveloping a vast region filled with icy remnants from the system's earliest days. This region forms a distant spherical halo so far away that even light takes days to cross it. This halo is not a place you could point to on a map and say, "There, that is the edge." It is more like a fading memory, a collection of objects only loosely bound, drifting at the outermost edge of belonging. To reach it would take tens of thousands of years at the speeds we currently know how to achieve. So when we say we have left the solar system, what we really mean is that we have left a layer of it. a surface, a breath, the deeper structure remains far beyond our grasp. This distinction matters because it highlights a recurring pattern in space exploration. We often mark progress by crossing boundaries that feel meaningful to us, even when they are not the boundaries that truly define the system we are trying to understand. Space does not object, it simply continues outward, indifferent to where we choose to draw our lines. There is also something quietly poetic about this. The sun, which feels so distant and small when seen from Earth, turns out to have a domain that is vast beyond everyday comprehension. Its influence stretches so far that even after decades of outward travel, our fastest messengers are still, in a gravitational sense, close to home. For a human listener, especially one resting and letting thoughts drift, this realization can be oddly comforting. It suggests that home is larger than we imagine, that the idea of belonging does not vanish the moment we step beyond a single boundary. The sun does not release its children easily. At the same time, it reinforces a sobering truth. If leaving the solar system in any deep sense takes tens of thousands of years, then reaching other stars lies in an entirely different category of challenge. The gap between outside the bubble and between stars is not a small step. It is a leap across scales that do not fit neatly into a human lifetime. This is why conversations about interstellar travel can feel strangely disconnected from reality. We speak of stars as destinations, but we rarely pause to notice how far we still are from even finishing our departure. We have not yet fully stepped out of our own system's long shadow. And that shadow is not a failure. It is a reminder. Space is layered. Progress happens in stages, not leaps. Each boundary crossed reveals another, larger one waiting patiently beyond. As this understanding settles in, the question of how far a human can travel in one lifetime becomes more precise. It is no longer about dramatic exits or symbolic firsts. It is about the slow accumulation of distance, the stubborn persistence of gravity, and the way the universe gently stretches the meaning of words like leave and arrive. The spacecraft that crossed the sun's wind boundary continues onward even now, carrying a faint whisper of humanity into the dark. It will not reach another star. It will not see the end of the sun's gravitational influence in any meaningful sense. But it has already taught us something essential. Leaving is not a single moment. It is a process measured not in announcements, but in patience. And as we drift forward from here, that patience will become an increasingly important companion. As the idea of leaving slowly unfolds, another quiet realization comes into focus. The solar system is not the tidy diagram we often carry in our heads. It is not a neat collection of planets circling politely around the sun, ending cleanly just beyond the last visible orbit. That image is useful for textbooks and classroom walls, but it hides a deeper truth about the scale of our home. In reality, the solar system is vast, diffuse, and gently untidy. It fades outward rather than stopping. And because of that, the phrase "still inside the solar system" means something very different than most of us imagine. When we picture the planets, we tend to think of them as the main event. Mercury close to the Sun, then Venus, Earth, Mars, and outward through the gas giants to the distant ice worlds. Beyond those last known planets, space feels empty, as if the system simply ends and the galaxy begins. But that emptiness is an illusion. Far beyond the outer planets lies a region that is less a place than a population. Countless icy bodies drift there, remnants from the earliest days of planetary formation. They move slowly, loosely bound by the sun's gravity, tracing wide, patient paths through the dark. This region forms a kind of halo around the sun, extending so far that it blurs into the background of the galaxy itself. To imagine its size, it helps to step away from numbers and lean into analogy. If the planets we know were clustered in a small village, this distant halo would stretch out like a countryside that never quite ends. You could travel for days and still feel as though you were somehow close to home, because the influence that defines home has not yet let go. For a human listener, this has an unexpected emotional effect. It reframes the idea of departure. Leaving the solar system is not like stepping off a ship onto a foreign shore. It is more like walking away from a campfire into the night, the warmth lingering long after the flames are out of sight. This matters because it reshapes how we think about progress through space. We often imagine that once we cross a certain line, we've entered a new chapter entirely. But space prefers gradients over lines. Belonging fades slowly. Influence thins gently. There is no dramatic moment when the sun simply stops mattering. And so, even after decades of outward travel, even after passing beyond the sun's wind and into quieter regions, our explorers are still moving within a structure that is unmistakably solar. The sun remains the dominant presence, not as light in the sky, but as a gravitational anchor quietly holding on. For human travel, this creates a sobering context. If it takes tens of thousands of years to fully drift beyond the outermost reaches of this extended system, then journeys to other stars are not simply a bit farther. They exist on an entirely different rung of the cosmic ladder. It also explains why phrases like interstellar space can be misleading. Technically, the space between stars begins as soon as the sun's wind gives way to the galaxy's background. But practically, in terms of motion, influence, and timescale, true interstellar travel begins much farther out, where the sun's grip finally loosens its hold. This layered structure of space mirrors something deeply human. Our lives, too, are built in layers. We move away from childhood, from familiar places, from old identities, yet traces of them linger long after we believe we have moved on. Distance does not erase influence, it only softens it. Seen this way, the solar system becomes less like a starting point and more like a long farewell. Each kilometre travelled outward is not a clean break, but a gradual thinning of connection. And that thinning takes far longer than our intuition expects. There is a quiet humility in this. Humanity has always been good at imagining destinations. We are less comfortable with the spaces in between, but space, quite literally, is mostly in between. It stretches patience. It stretches definitions. It stretches the meaning of near and far until they almost dissolve. As we rest with this idea, the original question gains new texture. How far could a human travel in one lifetime? Not just in terms of miles or stars, but in terms of truly leaving what shaped them. The answer, so far, seems to be not very far at all. And yet, this is not a failure. It is a clarification. It tells us that the challenge of space travel is not only about propulsion or courage, it is about scale, about aligning a brief, fragile span of human years with a universe that measures change in slow, patient arcs. As we continue drifting forward, we will soon encounter a much harsher barrier than distance alone. A barrier built not from space, but from the physics of motion itself. A place where adding more effort no longer brings proportional reward. For now, let this understanding settle gently. The solar system is not small, it is not quickly left behind. It is a vast, fading presence that reminds us how deeply rooted we are, even as we dream of wandering among the stars. With the vastness of our home system still lingering in the background, the mind naturally reaches for a familiar solution. If distance is the problem, then surely more power must be the answer. Bigger engines, more fuel, a stronger push. This line of thinking feels almost instinctive, shaped by centuries of travel on Earth, where adding energy usually does get you farther. In space, however, this intuition runs into a quiet and stubborn rule. A rule so simple that it feels almost unfair once you notice it. To go faster, you must carry fuel. To carry fuel, you must add mass. And to move that extra mass, you must carry even more fuel. The loop closes on itself. Imagine packing for a long hike. You bring food to fuel your body, but now imagine that the food itself has weight, and that weight requires more food to carry it. Soon, you are packing food to carry food to carry food. At some point, the backpack becomes heavier than the hiker, and the journey stops making sense. This is not a failure of imagination. It is simply the way motion works when you rely on throwing mass backward to move forward. Rockets operate on this principle. They move by expelling material in the opposite direction of travel. Each burst of exhaust gives a small push, and many small pushes add up to great speed. On short journeys, or journeys confined to planetary neighbourhoods, this works beautifully. It has taken us to the Moon, to Mars, and beyond the outer planets. But when distances stretch into the realm between stars, the mathematics of fuel quietly takes control. You do not need to see the equations to feel their effect. Each additional bit of speed costs more fuel than the last. Not twice as much, not 10 times as much. More in a way that grows rapidly and relentlessly. This is why chemical rockets, powerful as they are, begin to feel strangely fragile when asked to do too much. They burn brightly and briefly. They excel at escape, but not at endurance. Asking them to carry a human across interstellar space is like asking a match to light the sun. The problem is not engineering skill. It is not a lack of courage or ambition. It is a structural limitation baked into how this kind of propulsion works. You can improve efficiency. You can refine designs. But you cannot escape the basic rule. The more you carry, the harder it becomes to carry anything at all. There is another subtle cost hidden inside this rule. Fuel does not only get you moving, it also decides how you slow down. If you want to arrive somewhere rather than simply fly past it, you must spend energy to stop. That means carrying fuel not just for acceleration, but for braking as well. In effect, every journey has 2 mountains to climb, one at the beginning, one at the end. Both demand payment in mass. This is why many fast spacecraft we send into space are never meant to stop. They are designed to pass by, to take brief measurements, to send back fleeting glimpses as they rush through. Stopping is expensive, lingering is costly, staying is harder than leaving. For a human journey, this distinction becomes profound. A person cannot simply rush past a destination at extraordinary speed and call it arrival. Arrival implies rest, survival, and time, all of which require control, protection, and inevitably more mass. This is where the tyranny of fuel reveals itself fully. It does not merely limit speed, it limits the kinds of journeys that make sense for living beings. The faster you want to go, the more your ship begins to resemble a fuel tank with a small, fragile life tucked inside. At some point, the balance tips. Adding more fuel no longer feels like progress. It feels like burden. The ship grows heavier, more complex, more constrained by the very thing meant to set it free. This realization has shaped decades of space exploration, even when it's not spoken aloud. It is the reason engineers search so eagerly for alternatives. The reason they dream of engines that sip rather than gulp, that push gently over long spans instead of exploding in brief fury. The reason they imagine sails that catch light, or drives that hum quietly for years. But even these gentler methods must still respect the same underlying truth. Motion costs something. In space, that cost accumulates faster than intuition expects. As this idea settles in, the question of how far a human can travel in one lifetime sharpens again. It is no longer enough to ask how fast we can go. We must ask how much we can carry, how long we can sustain motion, and whether the price of speed leaves room for life itself. There is something quietly humbling in this. On Earth, we often solve problems by adding more power, more resources, more effort. Space teaches a different lesson. Sometimes, adding more only tightens the constraint. Sometimes, restraint is not a choice but a necessity. For now, let this thought rest gently. The universe is not blocking our way out of malice or indifference. It is simply enforcing a rule that has always been there, waiting patiently for us to notice. A rule that says distance cannot be cheated without consequence. As we drift onward, we will soon look at the clever ways humans have tried to work around this rule. Not to break it, but to bend it just enough to matter. Once the limits of fuel become clear, it is natural for the imagination to look for clever detours. If carrying enormous amounts of fuel is the problem, then perhaps the solution is to carry less of it, or to use it more gently, or to borrow energy from the universe itself, instead of hauling everything from Earth. This is where many of the most elegant ideas in space travel live, not in brute force, but in patience. One such idea is to let gravity do some of the work. By carefully flying past planets, a spacecraft can steal a little bit of their motion, gaining speed without burning extra fuel. This technique has been used successfully for decades. It is subtle, precise, and surprisingly powerful within the solar system. A spacecraft can weave through the planetary family like a skilled dancer, gaining momentum with each close encounter. But gravity assists come with an unspoken condition. They only work where there are planets to assist you. Once you leave the sun's neighbourhood behind, there are no convenient giants waiting to lend a push. Gravity is generous close to home, but silent in the dark between stars. Another approach is to trade explosive force for endurance. Instead of burning fuel all at once, some engines push gently but continuously. They whisper rather than roar. Over months and years, that steady whisper can build impressive speed. These engines are marvels of efficiency, squeezing every possible bit of motion from their fuel. For robotic explorers, this is a gift. They do not get bored. They do not age. They do not mind waiting years for a journey to unfold. But for humans, time is not so forgiving. Even with constant acceleration, these gentle pushes still lead to voyages measured in thousands of years when aimed at nearby stars. The engines are efficient, but the universe remains large. There are also ideas that do not involve engines at all, at least not in the traditional sense. Imagine a sail not made of cloth, but of an impossibly thin, reflective material. Instead of catching wind, it catches light. Photons from the sun, or from powerful lasers near Earth, bounce off the sail and transfer a tiny bit of momentum. Over time, that gentle pressure can push a craft to remarkable speeds. This idea is beautiful in its simplicity. No fuel tanks, no exhaust, just light and patience. And yet, even here, limits quietly assert themselves. Light spreads out as it travels. Its push weakens with distance. A sail accelerated near Earth must eventually leave its light source behind. And perhaps more importantly, sails are excellent at leaving, but deeply challenged when it comes time to stop. Slowing down without fuel is not trivial. Arrival, once again, proves harder than departure. Some concepts take a bolder step. They imagine engines powered by nuclear reactions, or even by the annihilation of matter itself. These ideas promise energy densities far beyond chemical fuel. On paper, they look like the long-awaited key to the stars. In reality, they bring new layers of difficulty. Handling such energy safely is a challenge unlike any we have faced before. Shielding a human crew from radiation, managing heat, and building structures that can survive for decades or centuries under such stress all remain unresolved problems. The engines grow powerful, but the human inside the ship grows increasingly vulnerable. There is a pattern here, gentle but persistent. Each improvement solves one problem while revealing another. More efficient engines reduce fuel mass, but not enough to collapse interstellar distances into human time. Powerful engines promise speed, but at the cost of safety and control. Elegant propulsion avoids fuel entirely, but struggles with braking and direction. Taken together, these ideas form a kind of quiet chorus. They all say the same thing in different voices. Within the framework of known physics, technology can help, but it cannot perform miracles. It can shorten journeys measured in tens of thousands of years to journeys measured in thousands. It can make exploration more graceful, more precise, more sustainable. But it does not by itself turn a human lifetime into a ticket to the stars. This is an important realization, not because it closes doors, but because it tells us where not to keep knocking. If we want to go farther than technology alone allows, we must look beyond engines and fuel. We must look at the structure of time itself. This is where the story begins to change tone. Up to now, the universe has felt like a series of expanding obstacles: distance, fuel, scale, each one politely refusing to bend. But hidden beneath these constraints is a feature of reality that behaves very differently. A feature that does not shrink distance, but changes how distance is experienced. We're approaching that idea now, slowly, carefully, without equations or clocks racing across the screen, just the quiet realization that speed does more than move you through space, it changes how you move through time. For the moment, let this thought remain just out of reach, like a door you have not yet opened. The engines we know can take us only so far. To go farther, we will need something stranger, something woven into the fabric of the universe itself, and as we continue, we will see that the true path forward does not begin with more thrust, but with a different way of counting the years. Up to this point, every obstacle we've met has felt familiar in a quiet way. Distance was too large, fuel was too heavy. Our tools, however clever, simply weren't built for the scale of the universe. Each limitation felt like a wall made of space itself. But now something subtler begins to happen. We reach a place where the wall is no longer made of distance, or engines, or mass. Instead, it is made of time. And unlike distance, time does not behave the same way everywhere. In everyday life, time feels wonderfully reliable. A second passes, then another. Clocks agree with each other. Calendars line up. If you and a friend part ways in the morning and meet again in the evening, you can safely assume that the same hours have passed for both of you. This shared rhythm is so deeply woven into daily life that we rarely question it. Space, however, does question it, quietly, politely, and with enormous consequences. More than a century ago, scientists began to notice something strange when they followed the logic of motion all the way to its limits. If you move faster and faster, approaching the greatest speed the universe allows, time itself begins to stretch, not as an illusion, not as a trick of perception, but as a real, physical effect. At first, the stretching is gentle, almost unnoticeable. A clock moving quickly ticks just a little more slowly than one at rest. The difference is so small that it takes careful instruments to detect it. But as speed increases, the effect grows stronger. Time does not slow in a straight line. It slows more and more dramatically, as if resisting the idea of being rushed. To understand this without numbers, imagine two identical clocks. One stays comfortably at home. The other begins a long journey, moving faster and faster through space. When the travelling clock eventually returns, something unexpected happens. It shows less time has passed, not because it was broken, not because it was fooled, but because it genuinely experienced fewer moments along the way. The clocks disagree. This disagreement is not a flaw, it is a feature of reality. Time is not a single river flowing evenly through the universe. It is more like a landscape shaped by motion and gravity, where different paths accumulate different amounts of experience. This realization opens a door that did not exist before. Until now, the question of travelling far in one lifetime seemed hopeless. Distance was too large, speed was too limited, but if time itself can slow down for the traveller, then a strange possibility appears. Perhaps the journey does not need to fit inside Earth's time. Perhaps it only needs to fit inside the traveller's. This is the loophole. Not a way around distance, but a way around the shared agreement about how time passes. Inside a fast-moving ship, days still feel like days. Meals are eaten, sleep comes and goes, conversations unfold at a familiar pace. The traveller does not feel stretched or distorted. Life continues normally from the inside, but outside the ship the universe moves on more quickly. Years pass, decades pass, centuries begin to pile up. The faster the ship moves, the more pronounced this difference becomes. Motion does not just carry the traveller through space, it quietly separates them from the time of everything else. There is something deeply unsettling and deeply beautiful about this idea. It suggests that time is not a universal stage on which all events play out together. It is personal, contextual, shaped by how you move through the cosmos. For the purpose of our question, this changes everything. If time can slow for the traveller, then a human lifetime can stretch farther than it ever could by speed alone. Not because the universe becomes smaller, but because the traveller's experience becomes compressed. A journey that takes thousands of years according to Earth's clocks might take only decades according to the clock on board the ship. From the inside, it feels like a long but manageable voyage. From the outside, it is an epic that spans generations. This is where intuition begins to fail in a gentle, almost dreamlike way. We're used to thinking of travel as movement through space. Here, travel becomes movement through time as well. The ship does not merely cross distance, it slips into a slower current of time. Importantly, nothing about this requires fantastical technology or imaginary physics. This behaviour of time has been measured, confirmed and quietly integrated into modern systems. Satellites orbiting Earth already experience tiny differences in time compared to clocks on the ground. These differences are small, but real. They're corrected every day to keep our navigation systems accurate. What we are exploring now is simply the extreme end of that same principle. The gentle slope becomes a steep hill. The whisper becomes a powerful effect. Still, it is important to remain calm and precise. This is not time travel in the cinematic sense. No one is jumping backward. No one is rewriting history. The traveller is not skipping moments. They're experiencing every second of their own life, just more slowly compared to the rest of the universe. And this brings with it an unspoken cost. If time slows for you, it speeds up for everything you leave behind. Friends age, civilizations change. The universe does not wait. The loophole allows you to go far, but it does not allow you to stay synchronized with home. For now, we don't need to follow that thought all the way to its emotional conclusion. It is enough to recognize that the door has opened. Not a door made of engines or fuel, but one made of the flexible, surprising nature of time itself. As we continue, we will step through that door carefully. We will see what it feels like to live inside slower time, and what it means for a human story to unfold while centuries pass elsewhere. Let this idea settle gently. Time, it turns out, is not as rigid as it feels, and in that softness lies the only true path that allows a human lifetime to stretch across the stars. Once the idea of time stretching begins to feel real, the next question arrives almost on its own. What would it actually feel like to live inside that slower flow? Not to calculate it, not to diagram it, but to inhabit it as a person with a body, a memory, and a finite number of mornings. To explore this, it helps to imagine a story rather than a theory. Picture two people who begin their lives together. They grow up under the same sky, share the same calendar, celebrate the same milestones. Their clocks agree on everything. Then, one of them leaves. Not dramatically, not in a blaze of light, but quietly, aboard a ship that will move fast enough for time itself to loosen its grip. The other stays behind. From the perspective of the traveller, life continues with a familiar rhythm. Days still have mornings and evenings. Meals arrive when hunger does. Sleep comes when tiredness sets in. There's nothing surreal about the passage of moments. The body ages, hair greys, muscles grow tired. The traveller lives a full, ordinary life, simply in an extraordinary place. But while that life unfolds on board, something very different is happening elsewhere. Back on Earth, time flows at its usual pace. Seasons turn, generations replace one another. The world reshapes itself slowly, then suddenly, then slowly again. What feels like a long journey to the traveller becomes a legend to those who remain. Names are remembered, then forgotten, then rediscovered in archives. This is not because time has stopped for the traveller. It is because time has become personal. Inside the ship, time belongs to the person experiencing it. Outside the ship, time belongs to the universe. The two no longer agree, and there is no referee to reconcile them. This difference is sometimes described with technical language, but the lived experience is much simpler. Imagine watching a candle burn. For the traveller, the candle burns steadily, melting wax second by second. For the outside world, that same candle seems to burn incredibly slowly, as if frozen between flickers. Both views are correct, they're just not compatible. The story of the two people diverges further as the years pass. Messages, if they are sent at all, become strange things. A letter from Earth might contain news of events that unfolded over decades, compressed into a single update. Births, deaths, revolutions, discoveries, all arriving together as if history itself had been fast-forwarded. Replies sent back from the ship travel the opposite way. By the time they arrive, the context that gave them meaning may no longer exist. The words are not wrong, they are simply late. This is the quiet truth of living inside slower time. It allows a human lifetime to stretch across immense distances, but it does so by letting go of synchronization. You do not outrun time, you step out of step with it. From the inside, this may feel manageable. The traveller experiences continuity. Memory remains intact. Identity is preserved. There is no sense of skipping ahead or losing moments. Life is lived one day at a time, just as it always has been. The cost is paid elsewhere. This idea is often illustrated with the story of twins, but it does not require family ties to be meaningful. It applies to any relationship anchored in shared time. Friends, cultures, languages, entire civilizations depend on a roughly common tempo. When that tempo breaks, connection becomes fragile. And yet, there is something profoundly human about this trade. Humans have always accepted separation in exchange for discovery. Sailors left familiar shores knowing they might never return to the same world they departed. Explorers vanished into unknown lands, emerging years later to societies that had moved on without them. What makes this different is not the separation itself, but its scale. Here, the gap is not years, but centuries. Not cultural shifts, but civilizational ones. The traveller does not merely return older, they return displaced in time. It is important to say this gently. There is no drama required to make the point. The physics does not punish the traveller, it simply follows its own rules. Time does not bend out of cruelty. It bends because motion demands it. For the purpose of our original question, this is the first moment where an answer begins to take shape. A human can travel astonishingly far in one lifetime, if that lifetime is measured by the traveller's own clock. Stars that would normally be unreachable become, in principle, accessible. The map of what is possible expands, but the expansion is one-sided. You can go far forward into the future of everything else. You cannot bring that future back with you. There is no return to the moment you left. The universe does not rewind to accommodate your arrival. This is why living inside slower time is less like conquering distance and more like choosing exile. Not exile from a place, but from a moment in history. You carry your era with you, sealed inside your memories while the outside world continues to rewrite itself. For some, this may sound tragic. For others, it may sound strangely peaceful. The noise of constant change is left behind. The traveller inhabits a narrow corridor of time, focused, quiet, self-contained. As we let this idea rest, it becomes clear that the loophole offered by time dilation is real, but not free. It gives distance in exchange for disconnection. It grants reach by dissolving simultaneity. In the next stretch of our journey, we will take this idea one step further. We will imagine not just living inside slower time, but doing so in a ship designed to feel familiar, almost Earth-like. A place where gravity still presses gently on the feet and life continues with comforting regularity, even as the universe outside races ahead. For now, allow this image to soften and settle. Two lives, once synchronized, drifting apart not in space, but in time. One lifetime unfolding quietly, while centuries ripple past elsewhere. This is what it means to live inside slower time. After imagining what it means to live inside slower time, another quiet question naturally arises. If a human were to spend decades aboard a fast-moving ship, what would daily life actually feel like? Not emotionally, not philosophically, but physically. Would the body recognize the journey as travel at all, or would it experience something closer to an ordinary life, gently removed from Earth? To explore this, we need to shift our attention from speed to sensation. One of the most difficult aspects of long-term spaceflight is not distance, but weightlessness. Human bodies evolved under a constant downward pull. Bones thicken in response to it. Muscles strengthen against it, fluids settle within it. Remove that pull for too long, and the body begins to quietly unravel. Muscles weaken, bones thin, balance becomes uncertain. Even the heart changes how it works. So if humans were ever to travel far through space, especially for decades, the absence of gravity would not be a minor inconvenience. It would be a central challenge. There is, however, a simple idea that addresses this problem without introducing anything exotic. If gravity is just acceleration felt by the body, then perhaps gravity does not need to come from a planet at all. Perhaps it can come from motion itself. Imagine standing in an elevator as it begins to rise. For a moment you feel heavier. The floor presses up against your feet. Your body reacts as if gravity has increased. That sensation is acceleration, and to your body, it is indistinguishable from gravity. Now imagine that sensation never stops. If a spacecraft were to accelerate steadily, gently, at a rate similar to what we feel standing on Earth, then the floor would always push upward. Your feet would always feel weight. Objects would fall when dropped, liquids would settle in cups. You could walk, sleep, cook and move much as you do now. From the inside, the ship would feel surprisingly normal. This idea is not a trick or a loophole. It follows directly from how motion and gravity are intertwined. The body does not know whether it is being pulled by a planet or pushed by a floor. It simply responds to the force it feels. What makes this idea especially intriguing is that it fits naturally with long journeys. Instead of burning fuel in a violent burst and coasting silently for years, the ship would push forward continuously. Half of the journey would be spent gradually building speed. At a chosen midpoint, the ship would turn around and continue accelerating in the opposite direction, slowing itself down until it arrived at its destination. From the perspective of the crew, this reversal would not feel dramatic. The direction of down would gently flip. What was once the floor would become the ceiling, and then, just as quietly, the new floor. Life would continue. Inside such a ship, days would have a familiar rhythm. People would wake to a gentle sense of weight. They would move through corridors that feel stable and grounded. Meals would be shared around tables instead of floating freely in the air. Sleep would come without the disorientation that weightlessness brings. Psychologically, this matters as much as physically. Long journeys are not sustained by technology alone. They are sustained by routine, by the small comforts of normalcy. A ship that feels like Earth is not a luxury. It is a requirement for mental health. Of course, imagining such a ship does not mean it is easy to build. The engineering challenges are enormous. Continuous acceleration for years requires energy on a scale far beyond what we currently command. The ship must be strong enough to endure constant stress. Its systems must function reliably for decades without external support. But the purpose of this idea is not to promise feasibility. It is to show that, in principle, a human journey across vast distances does not have to feel alien from the inside. The body does not need to be suspended in a fragile drifting state. It can inhabit a world that feels stable and familiar, even as the universe outside behaves in unfamiliar ways. This realization completes an important conceptual shift. Until now, the obstacles to interstellar travel have seemed overwhelmingly external. Space was too big. Fuel was too heavy. Time was too rigid. Now we see that at least one part of the problem bends gently to human needs. The ship does not need to fight the body. It can work with it. And yet, this comfort carries a quiet irony. The more normal life feels inside the ship, the more extraordinary the separation becomes outside it. While the crew eats meals and marks birthdays in a familiar way, entire eras pass elsewhere. The ship becomes a moving island of continuity, carrying a small slice of humanity through a future that no longer recognizes its origins. There is something both hopeful and haunting in this image. Hopeful because it shows that humans are not inherently incompatible with deep space. Haunting because it reveals how easily normal life can drift out of sync with the wider universe. As this idea settles, the narrative gently pivots again. We have found a way, at least in theory, to make long journeys livable. We have found a rhythm that suits the human body. But physics has not finished collecting its toll. The next question is not how life feels aboard the ship, but what the universe demands in return for such motion. The faster the ship moves, the steeper the price becomes. Energy rises, space grows harsher, and even the act of arriving begins to feel like climbing a mountain that never quite ends. For now, let the image remain soft and steady. A ship that feels like Earth, carrying ordinary lives through extraordinary distance, gravity beneath the feet, time slowing gently within, and beyond the hull, the universe rushing forward, indifferent, immense, and very much awake. With the image of a comfortable, Earth-like ship still gently in mind, we now arrive at a quieter but more unforgiving reality. The universe has allowed us to imagine a vessel where life feels normal, where time stretches kindly for those inside. But nothing in space is given freely. Every gift comes with a cost, and here, that cost rises like a mountain. At first, the climb seems manageable. When a ship begins to accelerate, the energy required feels familiar. Push a little harder. Go a little faster. This matches our everyday experience. Riding a bicycle, driving a car, even climbing a hill on foot, effort increases smoothly. We expect that relationship to continue. More effort brings more speed. But as a spacecraft approaches the greatest speed nature allows, the relationship quietly changes. Imagine climbing a mountain where each step upward feels heavier than the last. At the base, the path is gentle. You move easily. As you climb higher, the air thins, your legs tire. Each step demands more from your body. Eventually, the slope becomes so steep that progress slows to a crawl, no matter how determined you are. Speed behaves like this mountain. As a ship accelerates closer and closer to light speed, each additional increase demands more energy than the one before. Not just a little more, significantly more. The closer you get to that ultimate limit, the steeper the climb becomes. The summit never quite arrives. You can approach it endlessly, but you never stand on top. This is not because engines fail or materials break, though those are serious concerns on their own. It is because energy itself becomes increasingly reluctant to grant further speed. The universe resists being pushed this far. For the traveller, this has a practical implication. Continuous acceleration feels gentle inside the ship, but outside the energy cost grows enormous. Keeping that steady, Earth-like gravity beneath your feet requires an ever-increasing investment. The ship must pour more and more effort into gaining smaller and smaller returns in speed. And then there is the second half of the mountain. It is easy to forget that speed is not the same as arrival. To reach a destination and survive there, a ship must slow down. It must shed the speed it so carefully accumulated. This slowing is not free. It requires energy equal in spirit to what was spent accelerating in the first place. In other words, the mountain must be climbed twice. Once to leave, once to arrive. This realization reframes the journey in a subtle way. The challenge is not simply getting up to speed. It is carrying enough energy, control, and patience to come back down the other side. A ship that races past a star without slowing has not truly travelled there. It has merely passed by, a brief visitor unable to stop. For robotic probes, this is often acceptable. A fleeting glance can still yield valuable data. For humans, it is not. A human journey implies rest, shelter, and time spent somewhere. Arrival matters. As the energy mountain grows steeper, another quiet consequence appears. The ship itself becomes defined by what it carries. Systems must handle immense power. Structures must endure prolonged stress. Heat must be managed and dissipated without fail. Every layer added for safety and control adds weight, which in turn adds to the energy demanded by the climb. The ship begins to resemble the mountain it is climbing, heavy with its own necessities. This is the point where many visions of effortless interstellar travel quietly falter. Not because the physics is mysterious, but because it is honest. It insists that approaching light speed is not a sprint. It is a marathon run uphill, with no clear summit and no place to rest. Yet there is something important to hold on to here. The energy mountain does not forbid travel. It does not say no. It says this is the price. And prices, while daunting, can be weighed. In theory, if enough energy could be harnessed, managed, and sustained, a ship could continue climbing. It could live on the slope, moving ever faster, time stretching ever more gently inside. The physics allows this path to exist. It simply demands respect. This respect shapes the tone of everything that follows. The question of how far a human can travel in one lifetime is no longer about clever tricks or overlooked loopholes. It's about trade-offs, about deciding how much effort, complexity, and risk can be justified for each additional stretch of distance. And the mountain is only one part of the cost. As speed increases, the universe ahead of the ship begins to change character. Space itself, which once seemed empty and forgiving, grows sharper and more dangerous. The environment transforms, not because it has become hostile, but because motion has amplified its smallest elements into serious threats. For now, let the image of the mountain settle gently, a long, patient climb. Each step heavier than the last. Progress still possible, but never effortless. The ship moves forward, life inside remains calm, but the universe keeps careful track of the bill. In the next part of our journey, we will step beyond energy alone and look at what high speed does to the space ahead of a ship, how emptiness itself begins to push back, and why protection becomes as important as propulsion. For the moment, rest with this thought. Going far is not just about distance or time, it is about carrying the weight of motion itself, step by step, up a mountain that never truly ends. As the ship climbs higher up the energy mountain, something else begins to change, something quieter and more unsettling. Space, which once felt empty and forgiving, slowly reveals a different character. Not because it is suddenly filled with danger, but because speed has transformed the meaning of what was always there. At low speeds, space feels gentle, a vast, near-perfect vacuum, a place where objects drift freely, unbothered by friction or resistance. This emptiness is one of space's most comforting illusions. It makes us believe that once we escape gravity, the universe will simply open its arms and let us pass. But emptiness is not the same as nothingness. Even the quietest regions between stars contain traces of matter. Individual atoms wander there. Tiny grains of dust drift lazily through the dark. At human walking speeds, or even at the speeds of ordinary spacecraft, these particles are harmless. They pass unnoticed like motes of dust floating in a sunlit room. Speed changes that relationship. Imagine standing outside during a light rain. At first, the drops fall gently. They barely touch your skin. Now imagine riding a bicycle faster and faster through that same rain. The drops begin to sting, lean forward, and they strike your face more sharply. Increase your speed again, and what once felt soft becomes uncomfortable. At extreme speed, the rain no longer feels like rain at all. It feels like impact. This is what happens to space itself as a ship moves faster and faster. The sparse atoms and dust ahead of the ship do not increase in number, but their encounters with the ship become far more energetic. Each tiny particle arrives carrying far more force than its size suggests. From the ship's perspective, space grows sharp. An individual atom striking the front of a fast-moving ship does not behave like a gentle tap. It behaves more like a burst of radiation. Energy that was once spread out over vast distances is concentrated into a sudden, violent interaction. Multiply that by countless encounters over time, and the front of the ship becomes a place of constant bombardment. This is not a storm you can see. It is a silent, invisible rain of impacts, arriving relentlessly from the direction of travel. Protecting against this environment is one of the great unsolved challenges of high-speed human travel. Shielding can help, but shielding has weight. Weight demands more energy. More energy pushes the ship higher up the mountain we've already begun climbing. And shielding introduces another subtle problem. When high-energy particles strike protective material, they do not simply disappear, they interact, they scatter. Secondary radiation blooms outward, sometimes reaching deeper into the ship than the original particle might have. so the very act of protection can create new hazards. Engineers imagine clever solutions, layers of material designed to absorb energy gradually. Magnetic fields that attempt to guide charged particles away. Sacrificial surfaces that slowly erode instead of failing catastrophically. Each idea holds promise. Each adds complexity. None offer a simple escape. What makes this especially challenging for human travel is time. A brief exposure might be tolerable. A constant exposure over decades becomes a different matter entirely. Radiation accumulates quietly. Its damage is not always immediate. Cells may function normally for years before failing. Systems degrade slowly, often invisibly, until they no longer do. Living beings are not designed for an environment where the air itself has become hostile through motion alone. There is something deeply counterintuitive here. We often imagine danger in space as coming from dramatic sources, explosions, asteroids, supernovae, but at extreme speed danger comes from the smallest things, single atoms, flecks of dust, the quiet background of the universe itself. Speed amplifies everything. This realization deepens the sense that going faster is not simply a matter of stronger engines. It changes the character of the environment through which you move. It transforms a gentle emptiness into something abrasive, even violent, without any visible warning. And yet, it is important to keep the tone calm and clear. This is not a cosmic punishment. Space is not becoming angry. It is simply behaving according to consistent rules. Motion increases energy. Energy changes interactions. The universe does not adjust itself for comfort. For a human traveller, this adds another layer to the cost of distance. The ship must not only carry enough energy to climb the mountain of speed, it must also carry enough protection to survive the journey through sharpened space. Every solution feeds back into the same loop. More mass, more energy, more complexity. At this point in the journey, the path forward feels narrower. Not closed, but constrained. Each step requires more careful balance. The ship becomes less a vehicle and more a carefully managed ecosystem, constantly negotiating with its environment. As these challenges accumulate, something quietly shifts in the story. The idea of limitless acceleration fades. Not because it is forbidden, but because it demands sacrifices that grow harder to justify. The question of how far can you go begins to merge with how much can you endure, and there is still one more transformation waiting ahead. As speed increases further, the universe does something even stranger. It does not just grow sharper, it changes how it looks. Light itself rearranges. The sky ahead compresses. The familiar pattern of stars begins to distort, as if the cosmos were being gently folded toward the direction of travel. That visual transformation will be our next place to rest. For now, let this understanding settle softly. Space is not empty in the way we imagine. At high speed, it becomes a landscape of constant interaction, where even the smallest particles carry consequence. The universe does not need to add danger to stop us. It simply reveals what was always there. After considering how space itself grows sharper with speed, it is natural to imagine that the view outside the ship would remain mostly unchanged. Stars would still hang quietly in the darkness, distant and patient, indifferent to the traveller's motion. From everyday experience, we expect the sky to be a stable backdrop, a fixed dome under which events unfold. But at extreme speed, even the sky refuses to stay still. As a ship moves faster and faster, light behaves in ways that gently defy intuition. This is not because light changes its nature, but because motion reshapes how it reaches the traveller. The universe does not rearrange itself, yet it appears to do so from the ship's point of view. To sense what this means, imagine walking through falling snow on a calm winter night. When you move slowly, flakes drift down around you from all directions. Some land on your shoulders, others brush your face. The world feels evenly filled. Now imagine running forward. Suddenly, more flakes strike the front of your body. Fewer seem to arrive from behind. The snow has not changed, but your motion has given it a direction. Light behaves in a similar way. At modest speeds, the effect is subtle. Starlight still arrives from across the sky, and the familiar constellations hold their shape. But as speed increases, something strange begins to happen. Light from ahead of the ship becomes more concentrated. Light from the side starts to drift forward. Light from behind struggles to catch up at all. The sky begins to narrow. From inside the ship, it feels as though the universe is slowly folding itself toward the direction of travel. Stars that were once spread evenly across the heavens appear to crowd together ahead. The darkness behind grows deeper, quieter, almost empty. The forward view brightens, not because stars have become closer, but because their light is being gathered into a smaller region. At very high speed, this gathering becomes dramatic. The vast dome of the night sky compresses into a glowing patch ahead of the ship. What was once a full sphere of light becomes a focused window. The universe seems to be pouring itself forward, funneling everything into the path ahead. There is something deeply dreamlike about this image. The traveller does not feel rushed. Time inside the ship flows gently. Life continues with familiar rhythms. And yet, outside, the cosmos itself appears to be leaning in, as if curious about where the journey is going. Colour changes accompany this collapse of the sky. Light arriving from the front grows more energetic, shifting toward brighter, harsher hues. Light from behind loses energy, slipping into deeper reds before fading away entirely. The universe does not just rearrange its shape, it rearranges its palette. This transformation is not dangerous in itself, but it is revealing. It shows that motion at this scale does not merely carry you through space, it reshapes how space communicates with you. Light, the primary messenger of the universe, becomes directional, biased, sculpted by speed. For a human traveller, this has subtle psychological effects. The sky has always been a source of orientation. We look up and feel surrounded. We recognise patterns. We sense belonging within a larger whole. But when the sky collapses ahead of you, that sense of enclosure changes. The universe no longer feels like a sphere you inhabit. It feels like a corridor you're moving through. Behind the ship, darkness deepens. Ahead, brightness intensifies. The journey acquires a sense of forward inevitability. There is no temptation to look back. There is very little to see there. This visual narrowing mirrors the deeper themes of the journey. As speed increases, choices narrow. Trade-offs sharpen. The path forward becomes clearer but also more isolating. The traveller is no longer floating gently within the universe. They're cutting through it. And yet, it is important to keep the tone calm. This is not a violent collapse. It is a quiet one. The sky does not shatter. It folds, it gathers, it simplifies. From a scientific perspective, this effect is a natural consequence of how light and motion interact. From a human perspective, it feels symbolic. The universe, once wide and embracing, becomes focused and directional, reflecting the traveller's own commitment to the journey. As the sky compresses ahead, the sense of distance also changes. Faraway stars feel closer, not because they are within reach, but because their light arrives more intensely. The map of the cosmos becomes distorted, prioritizing what lies ahead and diminishing what lies behind. This is another reminder that extreme travel is not just a physical act, it reshapes perception. It alters what feels near and what feels distant, what feels present and what feels gone. As we prepare to move beyond this moment, the narrative gently shifts again. The sky's collapse is not a limit, it is a signal. It tells us that we are approaching a realm where intuition must be handled carefully, where the universe continues to obey its rules, but those rules produce experiences that feel unfamiliar and deeply strange. In the next part of our journey, we will step even farther back and look at the universe as a whole, not as a backdrop but as something dynamic, expanding and quietly moving away from us. We will see that even if a ship could endure speed, energy and hostile space, the universe itself sets boundaries that no engine can cross. For now, let the image linger softly, a ship moving forward through time, carrying ordinary lives inside. Ahead, the stars gather into a glowing focus. Behind, darkness stretches and fades. The universe does not resist the traveller. It simply reshapes itself around the act of motion. After watching the sky compress and fold around a fast-moving ship, it is tempting to believe that distance itself has finally surrendered. Stars appear brighter ahead. The universe feels focused, almost closer. From inside the journey, it can feel as though motion has unlocked the cosmos, that with enough patience and enough speed, every visible light might eventually become a destination. This is where the universe offers one of its quietest yet firmest reminders. Seeing is not the same as reaching. When we look out into space, we see light that has travelled for immense spans of time. Some of it began its journey before humans existed at all. Some of it left its source when the Earth was young, still cooling, still learning how to host life. The sky, in this sense, is a museum of moments, each point of light a message from a different era. Because light can travel freely, it brings the universe to us, but we cannot follow it everywhere it has been. To understand why, imagine standing on a shoreline at night, watching lanterns drift away on a slow-moving river. You can see their glow for a long time, even as the current carries them farther and farther downstream. At some point, though, no matter how fast you run along the bank, the river itself is moving too quickly. The lanterns continue to drift away, visible but unreachable. The universe behaves in a similar way, but on a far grander scale. Space itself is expanding. Not objects moving through space, but the space between objects gently stretching. Nearby regions drift apart slowly. Distant regions drift apart faster. Beyond a certain distance, that expansion outpaces any attempt to cross it, no matter how patient or persistent the traveller may be. This creates a subtle but profound boundary. There are regions of the universe whose light will always reach us. Their messages continue to arrive, carrying stories from the distant past. But there are also regions whose light is the last we will ever see, not because the light disappears, but because the space between us and its source stretches too quickly for new messages to catch up. This boundary is not marked by a wall or a line. It is not something a ship can approach and touch. It is more like a closing horizon, always present, always shifting, defining the limits of what can ever be reached. From a human perspective, this can feel deeply counterintuitive. We're used to thinking of space as a static stage, something we can traverse if we are clever enough. Expansion breaks that intuition. It turns the universe into a moving landscape, one where the destination itself may be carried away while you travel. Importantly, this is not a failure of technology. No engine, no matter how advanced, can overcome this boundary by brute force. The limitation does not come from speed, but from geometry. The fabric of space is stretching, and some regions are being carried beyond the reach of all future travellers. This distinction matters deeply for our question. Even if a human could endure long journeys, survive hostile space, manage immense energy demands, and live inside slower time, there would still be places that remain forever out of reach. Not because they are too far away now, but because they are moving away faster than any path can close. There is something strangely calming about this realization. The universe is not withholding secrets out of cruelty. It is simply structured in a way that makes some experiences fundamentally inaccessible. Boundaries exist, not as punishments, but as features of reality. For the traveller inside a fast-moving ship, this means that the visible universe is not a menu of destinations. It is a gallery. Some of what you see is already beyond your future, no matter how far you go. This does not make the universe smaller. In a sense, it makes it more precious. What is reachable matters more when not everything is. As this idea settles, the narrative shifts once again. The limits we are encountering are no longer about human weakness or technological immaturity. They are about the shape of the universe itself, about how space and time evolve together, setting boundaries that are woven into the cosmos. And yet, even these boundaries are not fixed forever. The universe is still changing. Its expansion is not steady. It is accelerating, which means that the map of what can be reached is quietly shrinking over time. Places that are accessible today may not remain so indefinitely. That realization will be our next resting place. For now, let this image remain gently in mind. A traveller moving steadily forward, life unfolding calmly inside the ship. Ahead, light continues to arrive from unimaginable distances, but not every glow is an invitation. Some are farewells, reaching us across a widening sea that no journey can ever cross. Once we accept that not everything we can see can be reached, another realization arrives quietly behind it. The boundary we've been describing is not standing still. It is drifting, slowly, steadily, and without any regard for intention. The universe is not just expanding, it is expanding faster with time. To picture this, imagine an old paper map laid out on a table. At first, the distances between cities are fixed. You can trace a route with your finger and feel confident that the destination will remain where it is while you travel. Now imagine the paper itself beginning to stretch, gently at first, almost imperceptibly. The cities drift apart, not because they are moving on the map, but because the map is growing. At some point, the stretching speeds up. This is what is happening to the universe. The space between distant galaxies is lengthening, and it is doing so at an increasing rate. Nearby regions remain connected. Farther regions slip away more quickly. And the farther something is, the more urgent its situation becomes. This turns the cosmos into a landscape with expiration dates. There are places that are reachable now in principle, but will not remain so forever. If a journey does not begin soon enough, the destination drifts beyond the closing boundary. Not dramatically, not suddenly. It simply becomes unreachable, the way a familiar road might quietly vanish beneath rising water. This idea reshapes how we think about exploration. It suggests that the universe is not a static opportunity waiting patiently to be explored. It is a moving target. The window for reaching certain regions is finite, even if that window spans billions of years. For a human traveller, this has a subtle emotional weight. It means that possibility itself has a lifespan. The future does not merely add options, it also removes them. From inside a fast-moving ship, this change is invisible. Life unfolds as usual. Time stretches gently. The traveller may feel that the universe is opening up, that more and more distance is falling within reach. But from the outside, the opposite may be happening. While the ship presses forward, the farthest destinations are slipping away one by one. This is not a failure of ambition. It is a feature of an evolving cosmos. There is something humbling about realizing that the universe itself sets deadlines, not deadlines we can read on a calendar, but ones written into the geometry of space. The message is not urgent in a human sense. It is calm, vast, and indifferent, and yet it is final. What makes this especially poignant is that light does not respect these deadlines in the same way. We will continue to see galaxies long after they have become unreachable. Their images will keep arriving, carrying stories from a time when connection was still possible. The sky becomes a record of lost opportunities, each distant glow a reminder that presence and reach are not the same thing. This can feel like loss, but it can also feel like clarity. The universe is not asking us to go everywhere. It is reminding us that not everything needs to be within reach to have meaning. Seeing, knowing, and understanding are forms of connection too, even when physical arrival is impossible. As we hold this idea gently, the central question of our journey evolves once again. How far can a human travel in one lifetime? No longer refers only to distance measured in light years or decades of personal time. It refers to how travel fits within a universe that is itself changing, closing some doors while opening others. In this light, speed becomes a double-edged gift. Move too slowly and destinations expire before you arrive. Move quickly and you may outrun your own era, arriving in a future that no longer remembers where you came from. The universe offers reach, but not without consequence. This balance between motion and loss runs quietly beneath everything we've explored so far. Energy demands, hostile space, bending time, collapsing skies, drifting horizons. They are not separate problems. They're facets of the same truth. Travelling far reshapes not just where you are, but when you belong. As we prepare to move into the final stretch of our journey, the focus begins to narrow. We've explored the physical limits. We've traced the cosmic boundaries. Now we turn inward, toward the human experience that unfolds within these constraints. What does it mean to send messages across centuries? To receive news from a home that no longer exists in any recognizable form? To arrive somewhere not just far away, but far ahead? For now, let this image settle softly. A universe that is slowly closing some of its doors, not out of malice, but out of motion. Destinations that fade not in darkness but in distance, and a traveller moving forward, carrying a lifetime within a narrowing window of possibility. After tracing the limits set by speed, energy, hostile space, and an expanding universe, the journey now turns inward. Distance is no longer the main challenge. Time is, not time as measured by clocks alone, but time as shared experience, memory, and connection. When a ship moves fast enough for time to slow inside it, communication becomes something strange and fragile. From the traveller's point of view, sending a message feels ordinary. Words are written, a signal is transmitted. There is a sense of reaching outward, of maintaining a thread back to home. But the universe does not carry messages the way we expect when time is no longer synchronized. Imagine writing a letter every month carefully describing your life, your thoughts, your small routines aboard the ship. You send these letters steadily, trusting that they will arrive in order, like pages in a diary. Now imagine that when those letters reach Earth, decades have passed between each arrival. Your monthly rhythm has stretched into a generational one. On Earth, your messages are no longer updates, they're artifacts. Each one arrives from a different era of your life, long after the context that shaped it has changed. A joke written lightly may be read in a world where its references no longer exist. A concern that felt urgent may arrive after it has already been resolved, forgotten, or replaced by entirely new worries. Communication becomes unbalanced. messages sent from Earth to the ship experience the opposite distortion. A single transmission may contain centuries of accumulated history. Names appear that you do not recognize. Events are summarized because there is no time to explain them fully. The tone is distant, not because those writing are cold, but because compression leaves little room for intimacy. For the traveller, receiving such messages can feel like watching a time-lapse of human civilization. Entire arcs of history unfold between meals. Cultures rise and fade between sleep cycles. The outside world becomes something you observe rather than inhabit. This is not a failure of technology. Signals travel faithfully at the speed the universe allows. The distortion arises because time itself has stretched differently along different paths. Communication remains possible, but conversation does not. Conversation requires shared time. Without it, connection thins. Emotional immediacy dissolves. You may know what has happened, but you cannot be present for it. You become a witness rather than a participant. There is a quiet loneliness embedded in this arrangement. Not the sharp loneliness of isolation, but a soft, persistent distance. The sense that home is no longer a place you can return to, even if messages continue to arrive. Over time, the language of those messages changes. Words drift, meanings shift, expressions evolve. You may find yourself rereading sentences to understand not what is being said, but how it is being said. Language itself becomes a marker of separation. This transformation does not happen all at once. It unfolds gently over years of ship time. At first, the delay feels manageable. Then it grows, slowly enough that adaptation feels natural, but steadily enough that reversal becomes impossible. Eventually, Peru, there comes a moment when the traveller realises something profound. Home has not disappeared. It has moved on. There is no catastrophe associated with this realisation. No sudden loss. Just the quiet understanding that the relationship has changed permanently. The connection exists, but it no longer defines daily life. At this stage, messages from Earth resemble echoes. They carry information, but not presence. They are valuable, but they no longer anchor identity. The traveller begins to live more fully within the ship's own small society, within routines that make sense in slower time. This is how exile begins, not as a dramatic departure, but as a gradual shift of attention. Importantly, this exile is not imposed by force. It is chosen, knowingly or unknowingly, as the cost of reaching far distances. The physics does not demand emotional sacrifice, but it makes emotional continuity difficult. In this sense, interstellar travel becomes a negotiation between curiosity and belonging. You can carry your memories with you. You can preserve records. You can archive voices and images. But you cannot preserve shared time, and shared time is the foundation of home. As this understanding settles, the journey approaches one of its most human moments. The traveller has not yet arrived anywhere new. They have not stepped onto another world, but already something irreversible has happened. They have crossed a boundary that no engine can reverse. They are living in a future that began without them. In the next part of our exploration, we will imagine what it means to arrive after such a journey, not just at a destination in a space, but at a moment in history where familiarity is dissolved. We will explore what it feels like to return as a stranger to time itself. For now, let this idea rest softly. Messages continue to travel. Signals still arrive. But home, as a shared moment, recedes quietly into memory. Distance has done its work not through space, but through time. After years, perhaps decades, of life unfolding inside the ship's slower rhythm, there comes a moment that once felt distant and abstract. The engines ease, motion softens, the long climb and careful descent finally give way to arrival. From the traveller's point of view, it feels earned. A lifetime of routines, memories, and quiet persistence has led to this place. The body's older, the mind is full, the journey feels complete, but arrival is never just about where you are. It is also about when you are. When the ship finally reaches a destination that can be called home again, the traveller steps into a world that has continued without them. Not paused, not waited, simply continued, layer upon layer, generation upon generation. This is where the deepest strangeness of relativistic travel reveals itself. Imagine leaving your home for what feels like 30 or 40 years, long enough for change, but not enough to erase familiarity. You expect new buildings, new technologies, new customs. You expect adjustment. But you still recognize the foundations. The language sounds familiar. The cultural rhythm feels legible. Now imagine leaving for centuries. When the traveller returns, the first shock is not technological. It is cultural silence. References fall flat. Gestures carry different meanings. Words still exist, but they have drifted. The traveller speaks fluently, yet sounds old-fashioned, as if quoting a book no one reads anymore. History has moved on, and it has done so without memory of the traveller as a living person. At best, the traveller is a historical footnote. At worst, a curiosity, a preserved remnant of an earlier time, stepping carefully through a world that has no shared childhood with them. This is not because the future is unkind, it is because time is thorough. Every society builds itself layer by layer, each generation standing on assumptions inherited from the last. The traveller has skipped those layers. They have leapt across centuries without absorbing the gradual changes that make a culture feel natural from the inside. So even familiar places feel slightly wrong. Streets may occupy the same ground, but their meaning has shifted. Institutions still exist, but their values have evolved. Even emotions carry new expressions. The traveller must learn again how to belong. This learning is not impossible. Humans are adaptable. But adaptation usually works best when change arrives slowly, allowing identity to bend without breaking. Here, change has arrived once. Arrival becomes a kind of second journey, one that unfolds entirely within the mind. There's also the weight of perspective. The traveller carries memories of a world that no longer exists. They remember voices that have no descendants. They recall events that have faded into distant history. Their internal timeline does not match the world's external one. This mismatch can feel isolating in a way that distance alone never was. Even admiration can feel alienating. The traveller may be celebrated as proof that humanity once dared greatly, once reached far, but admiration places the traveller on a pedestal, not within a community. Being honoured is not the same as being understood. In quiet moments, the traveller may realise something unexpected. The ship, not the destination, has become their true home. The long years of shared routines, the familiar walls, the small society that existed inside slower time. That was the last place where life unfolded in sync. Everything after that feels like translation. This realisation does not arrive with despair. It arrives with clarity. Travel across extreme time does not end with return. It ends with transformation. You do not come back unchanged. You come back unmatched to the moment you left, and yet there is dignity in this outcome. The traveller has seen what few ever will. They have lived through a personal lifetime while the universe aged around them. They have carried a piece of humanity forward, intact, across an ocean of time. They are not lost. They are simply out of phase. This is the final cost of travelling far in one lifetime. Not physical danger, not technological strain, but temporal displacement. You are present, alive, thinking, feeling. But you belong to a different chapter of the human story. As we prepare for the final reflection, the question shifts one last time. The issue is no longer whether such travel is possible. In principle, it is. The deeper question is whether distance alone is the right measure of success. In the final session, we will gather all of these threads together: speed, time, energy, horizons, and human cost. And we will ask a quieter, more personal question, not how far a human can go, but what it truly means to do so. For now, let this image rest gently. A traveller stepping into a future that feels both wondrous and unfamiliar. Alive, capable, and deeply out of sync. Not because something went wrong, but because the universe kept moving while they chose to move differently. After following this long, careful journey through distance, speed, energy, time, and consequence, the original question returns one final time. It sounds the same as it did at the beginning, but it no longer means the same thing. How far can a human travel in one lifetime? At first, the answer seemed purely physical. We measured speed, we counted years, we traced routes between stars and galaxies. We asked how far engines could push us, how long bodies could endure, how cleverly time itself might be bent. But now, after walking every step of this path, the answer becomes quieter and more complex. A human can travel astonishingly far. With enough speed, time slows. With enough patience, distances that once seemed impossible begin to shrink. In a single lifetime measured by the traveller's own clock, it is possible to cross regions of space that would take thousands, even millions of years according to Earth's calendars. In that sense, the universe opens wide, and yet every opening comes paired with a narrowing. The farther you go, the more you drift away from shared time. The more distance you gain, the more connection thins. You do not just leave places behind, you leave moments behind. You move forward into futures that cannot wait for you, and you cannot return to the moment you departed. This is the central truth that physics reveals so gently and so firmly. Travel at extreme scale is not just motion through space, it is motion through history. When we ask how far a human can go, we often imagine arrival as the goal, a new star, a distant world, a far-off galaxy. But arrival, we now see, is only half the story. What matters just as much is what arrives with you. You bring your memories, your language, your values, your sense of home. And as the universe moves on without you, those things become rarer, more fragile, more out of place. So perhaps the more honest question is not how far, but at what cost. You can go very far if you're willing to live inside slower time. You can go farther still if you accept that messages from home will fade into echoes. You can reach extraordinary distances if you're willing to arrive as a stranger to the era you once belonged to. Physics allows this. It does not forbid it, but it does not soften it either. There is no villain in this story, no single barrier standing in the way. The limits we encountered were not punishments for ambition. They were expressions of how the universe is structured. Energy grows heavy, space grows sharp, horizons drift away. Time itself becomes personal. Each limit whispered the same message in a different voice. You may go, but you cannot take everything with you. This realization reframes exploration in a deeply human way. Perhaps the ultimate frontier is not distance, but choice. Choosing what you value more. Reach or return, discovery or belonging, motion or continuity. None of these choices are wrong. They simply lead to different kinds of lives. For most of human history, travel has been about coming back. Even the longest voyages were shaped by the hope of return, of bringing stories home, of reconnecting with familiar ground. Interstellar travel, at its deepest extreme, quietly dissolves that expectation. Return becomes symbolic rather than literal, and that is not necessarily tragic. There is beauty in carrying a piece of humanity forward, intact, into places and times it would otherwise never touch. And there is meaning in becoming a bridge between eras, even if that bridge can only be crossed one way. There is dignity in choosing to go, fully aware of what will be lost. So how far can a human truly go? Physically, farther than intuition ever suggested, far enough to cross the stars within a single lifetime of lived experience. Far enough to witness a universe that feels immense and intimate at the same time, but temporally the journey is just as long. Every kilometre travelled forward is also a step away from shared time. Every acceleration carries you deeper into a future that does not remember your beginning. In the end, the universe does not measure your journey in distance. It measures it in separation. And perhaps that is the most important thing to understand before we ever set out. Not to discourage exploration, but to frame it honestly. To know that when we ask how far we can go, we're also asking who we are willing to leave behind and what version of ourselves we're prepared to become. As this exploration comes to rest, let the question soften rather than close. You do not need to choose an answer. The universe is not demanding one. It simply offers a landscape of possibilities, each shaped by its own costs and gifts. Some paths lead far outward, others lead deep inward, and many of the most meaningful journeys never leave home at all. Wherever you are listening from, in whatever moment you inhabit, you're already travelling through time at the only speed that guarantees connection. And in that shared motion, there is a kind of closeness that no engine can replace. And so, gently, we let the journey settle. Distance fades, time quiets, the universe continues expanding, indifferent and beautiful. And here, in this small shared moment, you're exactly where you belong.